C, part 3, tangent 30 degrees. So from here, tangent 30 degrees using the same triangle, tangent 30 degrees. Tangent is opposite over adjacent. What is the opposite side? BD over AD. Okay, so what is BD value? 1 over AD square root 3. Okay, is this a third? Should we leave it like this? How do we rationalize it? What negative? Times root 3 over? Times root 3 over? Root 3. Okay, so because I'm multiplying by the same, root 3 over root 3 is 1, right? Any number multiplied by 1 is still the same. I'm not changing the value. But by doing so, my denominator becomes 3. My numerator is square root 3. Okay? So they are equivalent answers. Now next, part D. Actually with this, can you all, Cosby, can you do part D by yourself already? Yes, you can. So let's talk about part E. Part E, we have the first one. Sine 120 degrees. So this angle over here is obtuse. It is greater than 90 degrees. So whenever you are doing E-maths, you have trigo ratio of an obtuse angle. I need you to consider the other angle that lies on a straight line adjacent to it. So what is the other angle? Adjacent to 120 degrees on a straight line. 60 degrees, right? Okay, so let's put down sine 60 degrees over here. Now is sine 120 equal to sine 60? Yes, they are. And from the triangle, can I get sine 60? What is sine 60 then? Okay, tell me the value. Can already. Root 3 over 2. Done. Okay, so that's part 1. Part 2, we have cosine 120 degrees. Again, it is an obtuse angle. So I want you to consider the angle that is adjacent to it on a straight line. What is that angle? 60 degrees again. Okay. Then we put down cosine again. Now, are they the same? Cosine 120, cosine 60, are they the same? No. What must I do to make them the same? Put a negative. Okay. So now, what is the value of cosine 60? No, listen carefully. What is the value of cosine 60? Cosine 60 is half. Okay, so the negative sign, I just carry it down. So our answer is negative half. Next, we have sine 150. Sine 150 degrees. Again, obtuse angle again. What is the angle adjacent to it on a straight line? If I'm not wrong, this word should be called supplementary. They add up to be 180, okay? So what is the supplementary angle of 150 degrees? 30, okay. So let's put down sine 30 degrees. Is the left-hand side equal to right-hand side? Yes, find out the answer. Part 4. Cosine 150 degrees equals to negative cosine 30 degrees. Get the answer and done. I want you to observe my working. What am I highlighting? Degrees. Is it important to put on the degrees over here? Why? Okay, the reason is because this degree over here is a unit, right? It's a measurement of an angle. Just like when we are dealing with speed and time. Sometimes the question gives you information in kilometers. Then after that, they give you information in meters. For example, meters per second. Then they give you distance in kilometers. What do you have to do? Can we work with kilometers and meters at the same time? No, you must convert them, right? So you must be consistent. The thing about angles is that there are different units for angles also. Subsequently, you'll be learning this unit called radian. And this unit, when we write it down, we actually don't need to write down the unit. What I'm saying is that when you see sine 120 like this, without a degree, it means that it is in radian. Okay? But because there are different units, then the answer will be different. You look at your calculator. Do you see a DEG and a RAD? in your calculator, okay, at the top of your calculator, do you see the capital letter D? Do you see a capital letter D? Yeah, that stands for degree. That's why all your life, you've been using trigo, you've been using your calculator, it didn't give you any problem. But the moment you start with radian mode, all your angles, your calculations will be slightly changed. You need to change the mode of your calculator. So right now, I'm stressing that if it is in, your angles are in degrees, you must write the degrees over here. Okay? Otherwise, I will take it that you are using radian mode, which we will cover subsequently. Okay, so this is for question 6 and 7 for your homework. Then I give you another question. Try it 9. Okay, let's flip to try it 9. Page 20. So in triangle ABC, it is always good to sketch it out, right? Triangle ABC, BC is 9. Okay, BC 9. CA is 7. And the area of ABC is 28. Find the possible values of A, C, B. Okay, so how do we go about doing this question? Okay, area of ABC equals to half. We can straight away substitute values, right? Don't need to write down, don't need to quote the formula. 9, 7, sine C. Okay. Yeah, we can shortcut like this. So what is the area of the triangle that is given to us? Okay, so half times 9 times 7 sine C equals to 28. So our unknown is C, isn't it? So we get rid of everything else. How do we get rid of the half and the 9 and the 7? Sine C equals to 28 times 2 divided by 9 times 7. Agree? Okay, so this value, how much is it? 8 over 9. Confirm, huh? Okay, then what is the value of C? Okay, so this angle is angle CAB, angle ACB equals to sine inverse. Sine inverse 8 over 9, isn't it? That's all? Or, is there an or? 180 degrees minus sine inverse 8 over 9. Why are there two answers? Why are there two answers? Because sine C is, it is positive. 8 over 9 is positive. Simply because sine C is positive, it means that there are two angles, two answers for C. Okay? So I think it was in what one? Is it? No, 2. Here. When sine theta is positive, there are two answers. Theta equals to sine inverse P or 180 minus sine inverse P. Okay? So that is if sine theta is positive, which is the case over here. So I have two answers and they are, the first one, what is the answer? 4 degrees or 180 minus, so we get 117.266 degrees. Okay, then you round off to 1 dp, 62.7 degrees or 117.3 degrees. Can? Does this make sense to you? Is it actually possible for me to draw two different triangles, whereas angle ACB has either 62.7 or 117.3 degrees, and yet the area is still 28? It is, right? Based on calculation, it should be possible. So in this diagram that I've just drawn, this angle over here, ACB, is it 62.7 or 117.3? Does this angle look like 62.7 or 117.3? Yeah, this is my 117.3. 117.3 degrees. So I am actually able to draw another triangle with the angle ACB at 62.7 degrees, but the area is still 28, so it should look like this. B to C, no change, still 9. Then now I'm going to draw angle BCA. It has to be smaller now because it is less than 90. So the same 7 cm. So now this over here is 62.7 degrees. And then I join it up. This is still 28 cm, 28 square centimeters. These two triangles have the same area with the same sides for BC and CA, but the angle in between those two sides are different. Okay? So don't fall for this trick. The trick over here is that there is a second answer. If you look at example 9, it gives you a clear explanation why. Okay? So your homework for 7.3 is question 6, 7, 8. For Emaths, yes. Okay, next one, Sine Rule, 7.4. Let's do a quick recap. For a triangle, what do we usually label the corners of the triangle? Big or small letters? Big letters. So this is A, B, and C. Angle, the corners, they represent the angles also. Okay, what about the sides? Do we use big or small letters? Small letters. Okay, what should I call this side? Okay, so small a. So it is important for you to know this convention because of the formula that you will be memorizing. So what do we call this side? What? B. From go opposite. So this is B. Okay, just as A over here, this is small a. So the last one, what is this side? Small c. So I try to make a distinction between my big C and my small c by varying the size. Okay, so what is the area of this triangle? Half A, B, sine C, which is the same as half B, C, sine A, which is the same as half sine B. Okay? So these are the three for finding the area of this triangle. Now I'm going to try and divide everything by, you see there's a half everywhere, right? What if I multiply throughout by 2? Would they still stay equal? So meaning every single one of these are now, okay, yes, this is the area of this is a formula for area of triangle. So now I'm going to remove these words over here. Now they are equal, isn't it? I'm going to multiply everything by 2. What happens to the half? They disappear, right? So I can cancel lah. Are they still equal? Okay, good. Let me erase them. Now I'm going to divide everything by A. Okay? Dividing everything by A, I will have B sine C equals to BC over A sine A equals to C sine B. Okay? So I divided by A, and then now I want to divide by B. So from here to here, I divided by A. Now I'm going to try and divide by B. So what do I have for the first one? Sine C equals to sine A equals to C over B sine B. Okay so far now? So I divided by A, I divided by B. What do you think I want to divide by? Yeah, I want to, divide by C this time. Divide by C, let's see what we have. Sine C over C equals to sine A over A equals to sine B over B. This is your sine rule. Meaning, for a triangle that is given to you, any kind of triangle in the world, as long as you name it like this, the sides, the corners of the triangle, capital letter A, B, and C, the opposite side to the corners, we call the lengths A, small b, small c, we are able to apply this formula. We call this the sine rule. Okay? So very simple to memorize. Sine A over A equals to sine B over B equals to sine C over C. Now, do you know why it is important to know how to name the triangle? Otherwise, you will get it all wrong, right? Can memorize already? Okay, good. Then there is a variation to it. Okay, from here, do you understand what reciprocal means? Okay, let me just do it quickly. Reciprocal of x is 1 over x. Reciprocal means you just take 1 over whatever that is. Okay, so reciprocal of A is, I cannot write equal, is 1 over A. Reciprocal of AB is 1 over AB. Basically, it's just 1 over, okay? So last one, reciprocal of A over B is B over A. How you know it's B over A? Okay, so 1 divided by A over B is the same as 1 divided by A over B, which is the same as 1 times B over A. So we just flip. We literally flip. Okay? So now, I want you to take reciprocal. Reciprocal. Okay, so sine C over C. Reciprocal, what do you get? So small c over sine angle C equals to sine A equals to B over sine B. Okay, they are equivalent mathematically. So when do we use this? We use this when we want to calculate, when we want to find out the sides of a triangle or angles of a triangle when you are given information that is, let's see, when you are given 2 angles and a side, or when you are given 2 sides and a non-equivalent angle. So let us go to an example to see how we apply this, okay? Textbook, page 24. Try it 11. Try it 11. We'll do it together. In triangle ABC, AC is 9, BAC is 56, ACB is 23. So we have 2 angles and a side. So for this question, right, I want you to write down in pencil 2 angles and a side. Okay, that is what the question gave you, 2 angles and a side. So use sine rule. Okay, now sketch the triangle out. AC is 9. BAC is 56. So B over here. 56 degrees. ACB is 23 degrees. Find the sides BC and AB. Okay? Do you understand the question, what they want? Okay, before we learn sine rule, how will you try and do this question? Before we learn sine rule, what will you do for this question? Try to find the angle, right? There is one unknown angle which we are sure we can get, right? Okay, what is that unknown angle? Angle ABC equals to 180 degrees minus 56 degrees minus 23 degrees. This is angle sum of triangle. Okay, how much is this? What? 101. Okay, 101 degrees. Okay, so we were given 2 angles and 1 side. Now, remember our drawing of the triangle? Our naming of the triangle, opposite sides, A and A, B and B, C and C. Then our sine rule, we've got sine C over C, sine A over A, sine B over B. The opposite sides, they are on top of each other, right, of the same fraction. Now look at our question over here. Do I have a pair of angle and side that are opposite each other? Angle B and small b, right? This 101 and 9, they form a pair. So are you able to write down the first fraction of sine rule? Okay, what do you want to write? 9, I heard 9 over sine 101 degrees. Important, huh? So 9 over sine 101 degrees has to be equal to this diagram don't have small d, small d, but you get to name the side using the capital letters. Okay, BC, I heard BC over sine 56 degrees. Is it also the same as something else? What is it? BA over sine 23 degrees. Okay? This is the application of our sine rule. Do you think you can solve for BC and BA? Yes, because sine 101 is just a number. Which you can get from a calculator. All these highlighted things, they are just numbers that you can get from a calculator. So use your calculator right now and tell me what is the value of BC. Who was shouting out the answer just now? Racy, how much is it? 7.601 cm. Round off to 7.60 cm. So that's BC. So what is BA? Racy, do you have BA already? How much? 3.980 580 5824. Okay, so 3.58 cm. Simple enough? $7.2. The obtuse angle one, is it? When you have those type of questions that you see in homework exercise 7.2, what kind of question is that? Okay, I want you to flip to your exercise. Once you have finished this, exercise 7.4, let us do question